Alright, so we got a review for our polynomials. It's a pretty long packet, so I'm going to break it up into two different videos, roughly halfway through. We're just working on both doing some algebra with polynomials and looking at the graphs there. Okay, so first one is just kind of vocabulary thing. Select all points where relative minimum values. That just means minimum is lower y value. Relative means compared to the stuff around it. So B has a lower y value than the points that are nearby it. E has a lower y value than the points that are nearby it. Even though E is higher than B, that doesn't matter because relative to the points that are near E, it is a minimum. And those are the only two relative minima. Some people might have chosen H. H is not a relative minimum because it isn't at the bottom of its like little neighborhood. There are points on the right side that are further down than H. So even though H is the point that was labeled, that's the lowest on the graph, it doesn't count as a relative minima. The only one are B and E. If I flipped the question and said relative maxima, then we would choose D and F. A, C, and G are called x-intercepts or zeros or roots. All right, we'll go through this kind of quickly. We've got three things we're identifying: degree, leading coefficient, constant value. So here, the degree is 3. The leading coefficient is 1. So degree, the leading coefficient is 1. Constant is 8. You might not see the leading coefficient, but it's the number that's in front of the highest power. The highest powered term is x cubed, so you can imagine 1x cubed. On the second one here, the degree is 5. The leading coefficient is 2. The constant is -6 because it doesn't have an x on it. Really not too much exciting happening here, just making sure you know the vocabulary. Degree is 4. Leading coefficient is 2. Constant is 1. Degree is 3. Leading coefficient is 1. Constant is 2. Be careful here, it's written out of order. Degree is 4. That's the highest powered term. Leading coefficient is 3. That's the constant in front of the highest term. Constant is -4.4. That's the term that doesn't have an x on it. I think this one's out of order too. Yep, degree is 3. LC, leading coefficient is -4. Constant, 5.4. Alright, so just some basic sort of vocabulary stuff. Now we get into doing a little bit more algebra. Which of these standard form equations is equivalent to blah, 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 blah? One strategy is to type this in as a graph, and then go through and graph this one, graph this one, graph this one, graph this one, and see which line up on top of each other. Then you have to look at 5 different graphs. That's kind of annoying. Another strategy is to multiply all this out. So x plus 1 times x minus 2. We go x squared, 1x minus 2x minus 2. Sorry, I made my box kind of small there. Here I've got x plus 4 and 3x plus 7. So x times 3x is 3x squared. 4 times 3x, x times 7, 4 times 7. So the first two terms became x squared minus 1x minus 2. I added these like terms in the middle to get the minus 1x. The second two factors became 3x squared plus 19x plus 28. Okay. Now, I could go through, let me rewrite that a little better. I could go through now and draw a big old nasty box. This is plus 28. That has 3 terms by 3 terms like this. I'm not going to go through all of this because it's a multiple choice. So we can like process of elimination. And I just don't feel like doing all these little multiplication problems. Alright, so let's look at the top left corner. That's going to be 3x to the 4th. Well, that's not going to be A. That's not going to be B. And then look at the bottom right corner. Negative 2 times 28 is negative 56. That's not going to be D. So just through process of elimination, we can see that C has to be the answer. I could have maybe even made that choice right at the outset of the problem, because if I just look at the x's, x times x times x times 3x gives me 3x to the fourth. Then I'm going to have a lot of other junk in the middle. And if I do constant times constant times constant times constant, I can see that I've got 1 times negative 2, that's minus 2, times 4, that's minus 8, times 7, that's minus 56. So I guess if I had looked at my answer choices first and seen how similar they are, I might have just focused on like what gets me the first term, what gets me the last term. All right. So maybe I could have been a little more efficient there. That's okay. Let's see. Diego wrote f of x equals x plus 2 times x minus 4 as an example of a function who has x-intercepts at negative 4 and 2. Well, let's try it. Let's plug 2 in. Is 2 plus 2 equal to 0? Nope. Is 2 minus 4 equal to 0? Nope. If I plug in x equals 2, 2 plus 2, 2 minus 4, that's equal to 4. That's equal to minus 2. That's minus 8. Definitely not 0. So he made a mistake. He thought that the number for the x-intercept is the same as the number inside the factor. That's not true. What we have to do instead is do the opposite of the x-intercept to get the factor. Now see what happens if I plug in 2. 2 minus 2 is 0. 2 plus 4 is 6. 2 minus 2. 2 plus 4. That's 0 times 6. That's 0. When you get an answer of 0, that's what it means to be an x-intercept. Think about an x-intercept. 2 comma 0. I plugged in 2. I got an answer of 0. Same idea if I plug in minus 4. This part doesn't equal 0, but that part does. All right, let's take that same idea and look at this next one. Write a possible equation for a polynomial whose graph has horizontal intercepts at 2, negative 1/2, and negative 3. I'll give you a couple options. Here's one option, probably the simplest. X minus 2, x plus 1/2, x plus 3. That definitely works. Here's another one that works. Put a 5 in front. Here's another one that works. Put a squared right there. Put a cubed over here. Those all still have x-intercepts at those same places. They said horizontal intercept in this question. It's an x-intercept. It's the same thing. Here's one other option. I could have written this as 2x plus 1. Because if you look at 2x plus 1, if you take your root, your horizontal intercept of negative 1/2, if you plug it in here, you get 0. But if you plug it in here, you also get 0. 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0. So there's an unlimited number, an infinite number of answers to that one. That's why it's phrased kind of funny. Write a possible equation. Here's even one more that works, just to be a little silly. I could write x minus 1, x plus pi, x minus 17, and then have go x minus 2, x plus 1/2, and I'll put my x plus 3 over here. This works, because it doesn't say that those are the only horizontal intercepts. So you could throw extra ones on there. I don't know why you would, but you could. All right, let's see. What polynomial gets larger and larger in the negative direction as x gets larger and larger in the negative direction? Okay, these sentences are hard for people a lot of times. So, which polynomial function gets larger and larger in the negative direction? When they talk about the function getting larger and larger in the negative direction, they mean going down. As x gets larger and larger in the negative direction, so that means x is going further to the left. So we need to think of a graph that on the left side is doing a curve like this. We don't know what's happening over here, but we know that on the left side there is an end pointing down to the left. All right, this one is positive and even, so that's going to be up on both sides. This one is positive and odd, so that's going to look like this. That one wins. The other ones are also positive and even, so they look like this. So it's B is the one. All right. We're going to cut the video in just a second once I finish number 7. So state the degree and end behavior of this. Degree is 3, and it has a leading coefficient of -1. So when it's an odd degree, it either looks like this or it looks like this. If it's an odd degree with a positive leading coefficient, it looks like this. If it's an odd degree with a negative leading coefficient, it looks like this. So the end behavior is as x goes to the right, y goes down, and as x goes to the left, y goes up. Alright, we'll cut the video here, pick back up in another video.